Ireland tonight giving a talk. I wanted me to remind you of that. So I'm Pauline Levick. I teach in digital studio practice, disciplinary arts and technology, among some other minor things. But I'll introduce our guest tonight, and then after the break, your TA, Joe Grenier, is going to give a talk about his work and influences. So there's still a full class tonight for those of you who are in class. For those of you who are not, welcome. Thanks for coming tonight to the Arts Now lectures. I actually don't have the official thank yous. Joe, do we need to thank anybody regularly for Artists Now?
Not necessarily.
Thanks to everybody for Artists Now. So I'm very pleased and happy tonight to introduce a friend and colleague of mine, David Bowen. Dave was born in 1975, and he got his undergraduate BFA from Terrence School of Art at Indiana University in 1999, and then went on to get his MFA at the University of Minnesota, where we met. We were in grad school together. He was a year ahead of me, and those were both in sculpture. And it was when he was interested in kinetic sculpture, and it was when he was in graduate school that he started working with programming that kinetic sculpture. And I was talking to him earlier that I still remember the night that I met him. A friend of mine, that was in my first year, and we had to go to this other building to see the sculpture lab. And Dave was like this, which is how I always think of Dave when I think of Dave. It's like this, hunched over and beating out on some little machines, little photosensitive robots. And he's just so excited. And then we have these other robots over here. And he's just, and he was explaining to me, and I was fascinated by his fascination, by his passion and his interest in what he was doing. And I've always found that to be the case with Dave. We spent the day together today, and it's just like, blah, 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 blah. It was just so fun to see what he's interested in next. And he and his wife have always impressed me with their studio practice work ethic and how much time they spend there just exploring and doing new things. And as you can see, it's really, really paid off. Some of Dave's recent awards, he was awarded an Arctic Circle Residency from the Farm Inc. in New York. I'll talk about that tonight. In 2011, he's also in the Alternative Now 2011 WRO Biennial and won Best of Show in, how do you pronounce it? Warsaw, Poland. He also won the grand prize in the Tokyo 13th Media Arts Festival and the third prize in the Vita 12.0 Art and Artificial Life International Awards in 2010. In 2012, 2011, 2010, he will have shows or has had shows at IBM in New York, in Slovenia, Berlin, Jerusalem, Tokyo. He was in the Surface Tension Future of Water show in Trinity College, Dublin, again in Poland, Vancouver, Canada, Mexico City, Belgium, Tokyo. He's showing all over the world. And I think one of the reasons is because of the very tangible nature of the way he uses data in his sculpture. So please help me in welcoming David Bowen.
Thank you, Pauline, for the generous introduction, and thank you all for coming out. So yeah, I'm just going to go through some videos. I'll explain each piece, what it does, and then show a video of it. So, and then I think we'll have a little time for questions afterwards. So, we can get the lights.
You are in control.
I'm in control.
Is it the instructor?
Nope.
No. And they have to take notes. So
you guys, are you okay to take notes like this? Is that good?
Maybe up a little bit.
Perfect.
Okay. You okay? All right. So, as Pauline mentioned, I chose the University of Minnesota in Minneapolis to sculpture. And I chose that program because to work with a national expert in kinetic sculpture, who's actually an alum of this school, Guy Baldwin, received his BFA or his MFA from the University of Wisconsin at Milwaukee several years ago. I was, as an undergrad at Harris School of Art, I was a big steel fabricator. I was doing a lot of steel fabrication and grinding and welding and things like that. And I started making those steel pieces move. I started making kinetic steel pieces. And as I said, chose University of Minnesota to work with this kinetic expert. And so this first piece I'll show you, 8 switches, was one of the first pieces I did in grad school, and one of the, actually the last steel piece that I was making. And so as you can see, it's fabricated with steel, and it has a twig and a series of 8 switches. And it's participatory in that the participant comes and chooses one of 8 toggle switches, and this twig will rotate around and turn off the switch and gesture in that direction. So that's what we have here. We have a very serious first-year grad student. If you notice this this bracket that connects the twig to the mechanism, it's kind of was inspired by sometimes if somebody breaks an arm or a leg, instead of making a cast, they'll actually have a bracket that connects directly to the bone. And I was really fascinated by that sort of disturbing, fascinating interface between a natural and mechanical system. So as you'll see, a lot of the work deals with combinations or interfaces between natural and mechanical systems. Yeah, as Colleen mentioned, I'm very much a geek, and I do a lot of looking around for new materials and new processes. And as an early grad student, I found this material called muscle wire, which is a nickel titanium alloy. When you run a low voltage current through it, it actually contracts like a muscle. It contracts about 10% of its length. And I thought, well, that's amazingly cool. There's got to be something I can do with that. And I found out it's not really very strong. So I ended up making it, setting up a piece where it did something very subtle. And in this case, we have a participant pushes a toggle switch, and then these leaves all subtly bend in unison after the switch is depressed. So this thin strand right here is the muscle wire. And this is, I'd like to just pause on this for just a second. This is kind of the brain of the device. This is an analog timer. And I mentioned Guy Baldwin before. He's a really expert at making these analog timers and just having simple micro switches and timing motors. And it's really a simple way to have an if-then. If this toggle switch is pushed, then this happens. And so this is kind of the very simple brain of all of these devices. So this piece, 50 drones, wanted to make a device that didn't have a literal natural object, like the previous 2 pieces had leaves and twigs. And I wanted to make something that more had a natural natural sort of behavior. So this can be seen as a flock of, or a crowd of people, or particles in this state of disbursement or school of fish, this sort of collective interactive behavior. The scale on this is about 10 feet high by about 20 to 30 inches wide. And this was featured in an exhibition at Ivy in New York called ArtBots, the Robot Talent Show. And I sold the curators on the idea that this was a self-arranging composition. So each individual unit has a small motor. It's a vibrating motor with offset weight. Very similar to what makes your cell phone vibrate when you get a call and vibrate. And so each one jostles and interacts with its neighbors independently. They're fabricated from aluminum and plastic. And you can see they all have these tethers, which kind of keep them confined, but also give them power, power motors. So this next piece is a very similar sort of setup with small motors, and this is one of the first explorations into mark making, I suppose, where these devices, instead of having offset weights, it's a very similar small motor, but instead of an offset weight, each device actually has a tooth. And so they actually carve into this foam as they are slowly lowered down, about a 1/4 inch every 24 hours. And so you'll see they kind of dig this sort of concave into the foam, and they also interact and sort of mimic a lifelike system that's feeding on this foam. And you'll see that there's a lot of static electricity that's generated, so each of the little motors gets kind of a pink foam jacket of foam that's stuck to them. Phototropic drawing device. This kind of came out of the desire to do something with those, like those two previous pieces with group behavior and collective interactivity, but give them a little bit more autonomy, kind of get rid of the wire tethers that you saw. And again, I geeked out on the internet and found out that there was a way to make a phototropic circuit using a solar panel and a capacitor and some transistors and some motors. And if wire them together in just the right way, you can make a small device that is attracted to light. So this is a robot that's very small, literally fits in the palm of your hand, and it has a solar panel with 2 eyes that look out and detect light. And it has 2 motors that power it, and it will go towards the most intense light that it detects. And the light is also what powers it via the solar panel. So literally this thing is looking for its food. So in a lot of ways it's kind of a living thing. The collective group behavior thing kind of failed because they all would go to the same light and get sort of hung up and not be very interesting. But I added a piece of soft pine charcoal to this device. And so I just had with this video we have a single device and 2 lights set up about 10 inches apart, and each light will be on for about 10 minutes. And the device will make its way, as you'll see from the video, from one pool of light to the next. And as it does, that soft pine charcoal makes a mark on paper. So the device's journey is tracked by this marker. And as you'll see from the video, it's quite sluggish when it's not under its direct pool of light, and when it finds its food, it gets very excited. It gets charged very quickly. So here we go. So I can set these guys up and let them draw. I can go teach a class and they're drawing, or go have a sandwich and they're still drawing. And at the end of this video, I have a drawing that was produced over a period of 4 months. So it's 10 lights arranged in a circle, and 2 devices went from light to light for 4 months. So there's literally millions of marks on the paper. So you can see actually the light started to burn into the paper a little bit too. Okay, so one of the really cool things about being at a big major research university like University of Minnesota is that there's a lot of, back in the day we didn't have physical computing professors and stuff like that. We had to kind of figure stuff out. And there's a lot of really smart people at research universities, even outside of the art department, that you can find and work with. And I found a professor who introduced me to these things called programmable microcontrollers, which of course you guys probably all know what that is, right? It's a little computer that plugs into your big computer, and you can program it to do pretty much anything you want. And these became amazing tools for me as a grad student. So this is one of the first pieces that I made with a programmable microcontroller called Resistor. And here we have an ultrasonic sensor, a sonar, basically. It sends out an ultrasonic chirp that bounces off of objects and then comes back to the sensor. And from that, data is compiled and determined a distance of objects from the sensor. So here we have a device that's rotating around 360 degrees, and the data is scaled and sent to a drawing arm. And so if objects are farther away, the drawing arm extends out. If objects are closer, it retracts back in. And so basically this makes a circular drawing of the space and the activity that takes place within it. This is just a crayon making these circular drawings. So as people walk past, they're detected and the device responds, or pedestals or walls in the space. So another early use of microcontrollers, I have this infrared drawing device. And this uses infrared sensors and emitters, infrared LEDs and infrared detectors, which is the same thing basically that is on the front of your remote control. So this is really, a lot of this stuff is really off-the-shelf kind of reconfigured technology, nothing really new or inventive here. I initially wanted this piece to be about surveillance in some ways, like it would track people as they move through the space, but as you will see from the video, it really turned into a sort of an unruly child, or maybe a highly specialized drawing instrument. And this is 4 sensors and 4 different directions that it can make marks based on the data that it's collecting. And of course, in Minnesota, you have to have a beer. It's even colder than this place. Uses piezoelectric speakers and very sensitive switches that I fabricated. So as the participant moves through the space, it generates very subtle air currents that are detected by these sensitive switches. And each of the 72 switches corresponds to one of 72 piezoelectric speakers that emit chirps based on which switches are pressed. So you see it sort of builds and then fades when the participant leaves the space. So in 2006, I had the opportunity to travel to this residency in this place called Balaton in Hungary, the Hungarian countryside. Right on the coast of, right on the shore of Lake Balaton, really beautiful country. And I didn't bring any of my technology with me. I just decided to work with what I had or what was available. So I had some steel wire and some soldering iron and some charcoal. And I decided to make a piece that would collect wind data. And incidentally, I was invited to participate in this exhibition that was curated by a good friend of mine that is a visual strategist at NASA Jet Propulsion Laboratory. And these are the guys that put the things up there on Mars, the robots on Mars. So really amazing technology. And one of the pieces that he wanted for this exhibition that he was curating that was data plus art, so it was kind of about data visualization, was this piece, one of the most low-tech pieces that I'll show, which I thought was kind of interesting. But really, if you think about like a lot of the direction that the work is going, it really has to do with data visualization and looking at data in aesthetic ways. So I would say that this is another way to look at that. So I was there for 2 weeks, and I would set these 3 devices up every day for about 8 hours every day, and just allow them to draw. So these are the drawings that were produced during that time. So as you can see, there were days that were rather windy and some days that were kind of subtle. And there were also days where it rained, and so the paper wrinkled a little bit. So yeah, that's the data. Yeah, in about 2007, I started working with Houseflies because I think they're kind of fascinating and interesting way to look at intersection between natural and mechanical laws of group behavior. And it turns out flies are very visually oriented. They respond to their surroundings very much by sight. And so also it's very absurd. A lot of these pieces are very absurd. That's my opinion. And so these flies are making some drawings. We have inside of this chamber down below here, we have maybe about 200 houseflies, and they are attracted to light, and they also like to go to the top of containers. And so up at the top here, we have a funnel and then 4 sensors. These are sensors called photoresistors, which are super cool sensors. They're really inexpensive and give you a lot of nice variation in data. And these photoresistors are sensitive enough to pick up the shadow of these flies. And so basically this drawing arm makes marks based on the movement of these flies. When they go into the chamber, the device is drawing, and when the flies exit the chamber, the drawing arm will retract and wait for a new fly to enter the chamber. And the paper will advance, the scroll of paper will advance. This piece actually debuted here in Milwaukee, a place called Hotcakes Gallery in 2007. This is a piece called the Growth Rendering Device. And this is a photoresistor. Actually, it's a photoresistor to detect the shadow of this pea plant. And that data is collected and sent to an old school HP inkjet, one of the first inkjets ever invented. And every time that photo sensor detects the shadow of that pea plant, one period is spit out, one dot of ink is spit out. And so basically it makes these very rasterized drawings of this pea plant. And it makes a new drawing every 24 hours. And there's a scroll of paper on one end, and the scroll advances when the drawing is finished. this, after this piece was at Hotcakes, it was at a gallery, or Rochester Art Center in Rochester, Minnesota, and they gave me a 50-foot wall down there to install it. The exhibition was over a period of 3 months. And about 2 months into that exhibition, the curator called me and said, "This plant is dying. What are we going to do?" And I said, "I think we should just leave it." And so I have this great scroll of the growth and thriving of this pea plant, and then as it started to wither and die and actually eventually fell over, the entire life cycle of the plant on this nice 50-foot scroll. And as you can see, it's not a perfect system. You know, sometimes the device makes mistakes, and I think these are kind of interesting. With this piece, I started exploring the idea of telepresence, which is you know, kind of transplanting a physical input from a great distance. And here we have a remote sonar drawing device. I was invited to participate in this exhibition at this place called Laboral in Gijón, Spain, which is the north coast of Spain. And I decided to set up a drawing arm, like I've shown previously, and a sensor array. In this case, it's an ultrasonic sensor array that detects people in the space from up to about 3 meters out into the space. And there's 4 sensors that correspond to each direction, up, down, left, and right. And there's a drawing arm and a sensor array in Spain, and a drawing arm and a sensor array at the University of Minnesota in Duluth, where I teach. And the data from Spain is sent in real time to the drawing arm in Minnesota. The data from Minnesota is sent in real time to the drawing arm in Spain. So drawings are being made across the Atlantic. New York in 2008, and I sold, it was about the brain, and I sold the curators on the idea that about 500 houseflies in a 12-inch diameter sphere would be the brain of an autonomous roving device. And so basically this device makes its way throughout the space based on the movement of these flies. And it also has sensors that detect the floor, and so it kind of stays within this ring, the black ring around the floor. Incidentally, my flies are very well cared for. They live on a diet of powdered milk and sugar, and they live for about 30 days inside of these species, which I'm told is longer than they live in the wild. The folks at Exeter gave me a call about 3 weeks into this exhibition, and I guess the rover had escaped from their black tape, and so the flies rebelled. So yeah, this is similar to the growth rendering device, only this is more of a 3D version, I guess, of that piece. There's a big community, or at least there was about 2 years ago, of folks doing DIY fused deposition modelers, which is a fancy word for 3D printer. And you can make one of these with the right specs and equipment. So RepRap was the original movement, and now it's moved to MakerBot, if you guys are familiar with that. So basically this is like an ultra precise hot glue gun. It takes plastic and melts it and makes a plastic model of this onion plant every 24 hours. And when it's finished producing the model, you'll see there's a conveyor belt that advances and just waits 24 hours for a new model to be produced. Here's a time lapse of that. I chose onions because of the way that they grow, because the device doesn't handle what are called undercuts very well, so it needs something underneath to build the next layer on. Back to some more Houseflies. This one's titled Fly Blimps. So inside of each one of these gondolas, hanging below these blimps, is about a sphere with about 50 Houseflies in it this time. And some sensors. I didn't talk about the sensors for these with the swarm piece, but it's a similar kind of sensor. It's like a photoresistor, only it's called a light to frequency converter. And it has an LED light pointed at the sensor. And every time the fly comes between the beam of the sensor and the light, that beam is broken, and that data is scaled and sent to motors that have propellers on them. So these devices make their way throughout the space based on the movement of these flies. I get my Houseflies online. You can get anything online. another telepresent piece. This one's titled Telepresent Wind. In this case, I have a device called an accelerometer. And if you have a smartphone or a Mac laptop, you have an accelerometer, which is a device that measures tilt or acceleration in X, Y in this case. And I have one of those small sensors connected to a device that's installed outdoors, one of these thin plant stalks. And as that plant stalk is going around, the accelerometer collects data from that movement, and that data is sent in real time to these devices. And this piece was installed, the sensor was installed in Duluth, Minnesota, my home, and the devices, the field of 42 devices here, was installed at a place called Laboratory of Art and Science Space in Moscow. So this is wind data from halfway across the world. Why the beard? I really started thinking about water quite a bit lately. And this is a series of pieces titled Telepresent Water. And for this particular one, I took my laptop with me on a ferry ride across Lake Superior and used the accelerometer in the laptop to collect the data from the movement of the ferry. And I also used these buoys, National Oceanographic and Atmospheric Administration buoys, NOAA, to collect data, and I'll explain that to you with the next piece. But there is a buoy in the middle of Lake Superior, and this was this ferry ride that I took was on a rather rough day. The day previous to this ferry ride, the largest waves anywhere that I could find in the world were on Lake Superior. It was a really, really rough day, and we took the ferry from Fulton, Michigan, which is in Upper Michigan, to Isle Royale, and it was a pretty rough ride for some folks that were prone to seasickness. But this is the data from that 3-hour ferry voyage. So I also, with this series, I also use, as I said, National Oceanographic and Atmospheric Administration. I'm sure you guys have heard of them. They have buoys all over the world that are used for tsunami warning system, or hurricane warning system, or navigation for ships. But each buoy has its own website. Each buoy on NOAA's site has its own website. So if you go to noaa.gov, you can get this map and select one of thousands of buoys on the Pacific, on the Atlantic, on Lake Michigan, on Lake Superior, and get onto that buoy's website and get information about water temperature, wind speed, wind direction, also wave height and wave period. And so for this piece, I'm pulling data from a buoy in the middle of the Pacific Ocean. And this was at the WRO Biennale in Wrocław in Poland. And this is using data from a buoy in the middle of the Pacific to recreate this waveform. So here we go from, obviously the data scale quite a bit, so going from about a 20-foot wave here to about 7 feet. Let's switch it over. So this is one of my most recent pieces here, and in this case I'm using about 500 houseflies to send Twitter messages. So they have their own Twitter handle, and you can follow them if you want to. They're tweeting right now in my studio, so if you'd like to check them out. There is a camera pointed at the keyboard for this piece, and as the flies fly over or land on the keys on the keyboard, whatever key is interacting with that character is typed into a little text box. And when either 140 characters is reached or the flies press the enter key, whatever is in the boxes is tweeted out. It's at fly colony. So yeah, check them out. I bet you can. They're tweeting right now. They kind of slowed down. It started about 3-4 weeks ago, and they're getting kind of geriatric, those flies. They sort of slowed down a little bit. They're pretty prolific. At least they were at the beginning. I said I think they've slowed down. I was checking them today. I think they're doing about one every hour now. So they really, yeah. So follow me at FlyCon if you'd like to, or just check it out. As Colleen mentioned earlier, I was fortunate enough to participate in a residency called the Arctic Circle. And this is a 2-week residency on a ship, on an ice-class 3-masted sailing ship. And it was near an island called Svalbard, which is disputed territory. It's Russia or Norway, whoever you ask. But it's about 10 degrees from the North Pole. And so I spent 2 weeks on this ship. My primary purpose was to collect wave data for the telepresent water pieces. But I took some cameras and a lot of other materials with me. And I have hundreds of hours of video and literally 50 million data points that I collected on this trip. And this last video that I'm going to show you is not really a piece, but I just wanted to share it with you guys. I had some of those Go videos, some of those inexpensive HD video cameras, and they allowed me to climb out on this thing called the bowsprit, which is the ship has a mast that kind of comes out in front of it. And I mounted one of those GoPro video cameras on the bowsprit and recorded for 8 hours. So just let it record for 8 hours. And so that's what we have here compressed into a couple minutes. You'll notice when everybody kind of comes out onto the deck of the ship and the ship kind of slows down, that's when we see a polar bear. We all got kind of excited about that. So. There we go. So that's what I do.
Anyone have a question for Dave?
I was wondering if the telepresent big ones that do the videos of the recording plan, if you had that, if it was, like they did it, if it was,
Yeah, I've done it both ways. I have had like a video on the device that's collecting the data. And I think I prefer to have that have it be serious, you know, kind of have it didactic and say, you know, this is what's happening, and not have that literal connection with it. But I've done it both ways for sure, having a video and not. And I think I prefer not.
Other people?
Sure.
A couple questions about your friends, the flies.
Yes.
So, have they ever tweeted anything intelligible?
No,
at least in human language.
I mean, I guess that depends on what you define as intelligible. No, not really. I mean, maybe you could give them enough time. I don't know, but it's really maybe more of a comment on. I think Twitter is kind of absurd, and the idea of updating constantly. I'm kind of taking a jab there. I'm not a real big Twitter guy. So.
Have you ever been contacted about animal rights issues regarding that?
I haven't, not yet. I have, I've had a couple comments here and there. But I do like to say that my flies are very well cared for quite a while. And so, but yeah, I mean, there's, yeah, they're flies. Yeah.
I have a couple of questions. First off, where do you get that many flies?
Online. It's an ideal food source for lizards or birds. You can get housefly pupa online for like 5 grams is about 500 flies, and that's about $5. But you can get a kilo of them.
And is it always conscious? I guess your interaction with the public, like you're viewing public, because the majority of these seem to have that interaction there.
Yeah, when it's a piece that is activated by a person, yeah, I like to, with all of them, maybe you notice, I really like to show, I really like to explain what's going on technically, and I really also with pieces show what's going on in terms of the mechanism, or I'd like it to be at least, somewhat magical, but more apparent of what's happening, like you are a direct participant with this. Might not always be clear, but I like that to be not hidden, I guess. I think I got one back there, yeah?
The autonomous machines that you've created, you showed them in the gallery space. Have you ever considered, or have you ever set them free, or like allowed them to traverse public space?
No, I mean, that could be interesting, yeah. Just kind of give them a little free rein. Yeah, no, not yet, but who knows, yeah. I mean, they do escape on their own, like that story that I told at Exit Art. Those blimps, those seem like they're a little in danger of escaping sometimes, for sure, yeah. Yeah.
I have a follow-up to that. How do you set constraints for the works?
Yeah, it usually is defined by the space. So yeah, in terms of this is available space for the devices to run. So yeah, I like to sort of set up the situation and allow it to have autonomy within obviously the confines of the space or the data or whatever. But there are a lot of elements that are outside of control, and I think it's these outside of the control things that tend to be the most interesting. Like I can tell, I'll get to you in just a second, but I'll tell an anecdote about that telepresent water piece. I installed, for the first time I installed one of those was in a gallery in Philadelphia called Esther Klein Gallery, about a year ago, actually. And that was using a buoy in the middle of the Pacific also. And on 3/11, the curator called me and said, this thing was freaking out, like what's going on here? And it was actually the tsunami moving across the Pacific. And I think it was more, not actual data, but I think the buoy got knocked out because the entire wave matrix was just kind of moving up and down. So I don't know if it was the actual, but yeah, really kind of a disturbing, but also fascinating sort of thing, unintentional thing that happened. Did I have one back here? Yeah.
I was just wondering what role you say nature plays in your work as far as, is it just inspiration or data collecting, or are you commenting?
I mean, I'm fascinated by, obviously, natural inputs. I bring that into, okay. I'm fascinated by the way in which we sort of have this idea that machines will behave in a very predictable sort of way, very calculated in programming and robots and all that. And I find the more I work with this kind of work, that's not necessarily the case. And maybe it's my lack of skill in programming or fabricating, but I like the sort of foibles or the mistakes or the sort of unpredictable outcomes. Likewise with the natural inputs. Then these natural systems that I can use, or that I've used, can be very predictable in a lot of ways. I mean, plants are really amazing engineers, and they're very predictable in the way that they grow and create their structure. Likewise, actually, believe it or not, flies are somewhat predictable too, in that they are, attracted to light source. They really like to work their way to the tops of containers, so I guess that's what kind of keeps me interested in. We have these sort of preconceived notions about this sort of dichotomy, and what I find is that these things aren't so separate. And the idea that a mechanism can have life, or a computer can have life, maybe it's just in characteristics, or maybe there's something more there. But I'm really fascinated by that sort of overlap, I guess. Yeah.
So I'm curious about you working with microprocessors and sometimes not working with them. I'm just wondering if that also kind of plays a role in like you conceptualizing these ideas for these pieces, or are they just a mere tool?
For sure, yeah. They are materials in a lot of ways, but they're materials that really expand the potential for variation, I guess, in terms of output and input. And like where I started from with my lecture and my studio practice with these analog inputs, where sort of limited in terms of the things that can occur. Whereas when you're dealing with larger amounts of data, the variation becomes more. There becomes more potential for variation or unpredictable outcome, I suppose. And so, I think maybe when I start to see the potential to use larger amounts of data as my skills as programming become better, or I work with new software, I become more fascinated by using this data to mimic or I don't know, use the natural world, I guess, in some ways. So yeah, I think the programming, it started off as a tool, or the microcontroller started off as a tool, but I think it's become more integral to what fascinates me about these kinds of things in terms of greater complexity. That's what I'm looking for, greater amounts of complexity. Yeah.
I'm interested in the importance of sound to you, like that sort of drone of the systems. That is important for if it has a certain
Most of the pieces do have a sound component that's, and some of them are literally sound pieces. I don't know that for the most part the sound is intentional, but I think that adds another lifelike characteristic to things, and so I don't want to make it go away. I embrace it. These words and numbers kind of give that. I mean, whenever you see something moving, of course you're going to assign it kind of a lifelike characteristic, but also hearing it.
Like wind and water, there's those kind of, there's that comparison too, the machine drone, like a natural drone.
Sure. Yeah, I think that's interesting. I haven't really thought about that so much, but that can be good.
What role does drawing play in your work?
Yeah,
Do you see them mostly as residue product?
in some ways, yeah. I mean, I think it's, well, I'm an art school kid, and I very much, at Heron School of Art was sitting in front of drawing paper, making marks myself, and so in a lot of ways, the way the arm is constructed, I'm thinking about, making marks on paper and gesture and that sort of thing, and it is, a particular way of visualizing data visualization and mark making, and sort of the idea of collecting data in a cumulative sort of way. Aesthetic, data, I think, I guess that's the title of the talk. Yeah. So, I think I most identify with drawing and mark making as a sort of qualified way of visualizing data, I suppose.
Have you moved away from it in your recent work?
Yeah, I suppose so. Yeah, you can see that with a lot of the more recent recent pieces. So, who knows? I guess it comes and goes, right? I mean, there's something interesting about the Twitter, you know, the idea that these things are archived forever, you know, and I think if you look at those things, I don't know if you care to, they really become more visual. I mean, they're not, the flies aren't really saying anything profound, but they are kind of interesting visual. I like to scroll through them, and so I guess I look at those as marks in some ways. Oh, sorry.
Go back to the piece you had about the tsunami and how that kind of malfunctioned. How often do you have to perform maintenance on these pieces, or when they're installed? Like, it seems so mechanical and so many things to go wrong. How often do you have to go and actually back to the studio and review these things?
I generally, I spend about a third of my time in the studio fabricating or making, a third of the time programming, and then a third of the time debugging or just running and waiting for something to break. And yeah, I do exhibit a lot of these things, and sometimes things do break, and sometimes you gotta take the next flight out and do some repairs, or if there's somebody, like a technician there that can do repairs. Sometimes I get lucky. I mean, I think those wave pieces seem like they're pretty durable. I've been fortunate with that. But, you know, as much off-the-shelf kind of stuff that I can use. I mean, engineers know how to do it a lot better than we do, I think, and so you can use it's already been tested. Generally try to do that as much as I can. But also, I mean, again, as the anecdote with the pea plant dying, I mean, sometimes things can break in interesting ways too. I mean, sometimes also I think that adds something else to the piece, like maybe it has a life cycle. You know, maybe it does start to decay and slow down or fall apart. And I think that could be part of it too.
All right, thanks a lot. Joe, when do you want people back?
They can be back at like 8:30 is cool. So
8:30?
yeah.
All right,
Thank you.
get Dave.
Thank you guys.